Hi everyone, we're going to move on to Chapter 4, Section 3, and this section is on graphing linear functions using intercepts. So far we have been graphing linear functions by making a table of ordered pairs. We can either start with a particular domain set that has been given to us, or we can make our own and graph that linear function using those pairs in our table. Now we're going to learn how to graph linear functions using the x and y intercepts. So let's talk about what those intercepts are. The x-intercept here is something that happens on the xy coordinate plane when the x-intercept intersects, or the linear function intersects, the x-axis. Intersects here. My pen is not working. So that's where it intersects the x-axis. As you know, the x-axis here is the horizontal axis. Let's go ahead and label that. And the y-axis is the vertical axis. And here you can see a particular linear function, and right there where it crosses that x-axis is called the x-intercept. And likewise, the y-intercept on the coordinate plane is where the linear function intersects again, this time the y-axis. And the y-axis, as we said, is vertical, straight up and down. So here is our linear function, and right here is the y-intercept. And so with these 2 points, we can just take our ruler and graph those 2 points, and then take our ruler and draw a line in between them. Now, I do want to caution you that, as we've done in the past, when we create this table of multiple pairs, it is very helpful because if we end up with some of these points that are clearly not forming a line, then we know we made some kind of error arithmetically I should say, or we made an error graphing our points, which is very easy to do. So when we use just 2 points, such as the intercepts, it can be a little tricky because you might not pick up an error. However, having can be very convenient. Now, many of you started on Thursday and Friday the Khan Academy assignment where we were given a table of just 2 ordered pairs, and then we were told to graph them. So let's take a look at what that is. Here we have a linear function, 6x plus 7y equals 4x plus 4i. And we were given first an x value of -3, and we're asked to solve for y. So let's do that right now. We have 6x plus 7y equals 4x plus 4y. We're going to substitute in x equals -3 because that's what we're told it equals. So I'm going to replace all of my values of x with -3, and then I'm going to solve for y. So I've got 4 times -3 here plus 4y. -18 plus 7y equals -12 plus 4y. Now I'm solving equations here. I need to get the y terms together and on the same side, and I need to get the constants together on the opposite side. I am going to subtract 4y from this side and bring it over here with 7y. So I end up with -18 plus 3y equals -12, and these cancel. Now I'm going to bring that 18 over here with the 12. So I end up here with cancellation. 3y equals 6. I'm going to divide both sides by 3. And I obtain y equals 2. So here I know y equals 2. I'm going to do the exact same process now when y equals -4. By the way, I can go ahead and graph this pair here, -3, +2. I'm going to go left 3 and up 2 to graph that point, and that would be right here. And then we're going to do the same process. So we've got, so let's start substituting in. I'm going to have to use my graph area here. 6x plus 7y equals 4x plus 4y. I'm going to substitute in now y equals negative 4, because as you can see, we're told that y equals negative 4. And then I'm going to solve for x. 6x plus 7, I'm going to replace my y with negative 4, equals 4x plus 4, and again, I'm going to replace that y with negative 4. I have 6x minus 28 equals 4x minus 16. I'm going to subtract 4x from both sides because I need to get those x terms together. And I have 6x minus 4x is 2x, and minus 28 equals, these cancel, negative 16. I'm going to add 28 to both sides. And 2x comes down, equals negative 16 plus 28 is positive 12, and x equals 6. So I'm going to substitute that in here into my table. 6, negative 4. That's tough to see given that I've written all over my graph here. I'm going to go over positive 6 and down negative 4, which is right here. And I'm going to take a ruler and I'm going to make a nice straight line in between those 2 points. Okay, now why did I do that? I wanted to show you that's kind of a lot of work coming up with those 2 points. And we can make our life much, much simpler by using the x and y intercepts. That's where the line will cross the x and y axis. The reason why it's much simpler is because they happen when either x equals 0 or y equals 0, so it makes our work a lot easier. Here, the very first row we have is x equals 0. Well, now when x equals 0, that's, x equals 0 right here on the y-axis. So when x equals 0, this is the y-intercept. And likewise, when y equals 0 right here, everywhere on this line, y is not positive, y is not negative, y is right on that x-axis. So that would be our x-intercept. So let's take our function and substitute x equals 0. I'm going to put this right here. 6 times 0 plus 2y equals 12 plus 2 times 0. So these zeros just kind of make everything much easier, because anything times 0 is 0. 2y equals 12, so y equals 6. Our y-intercept happens at y equals 6. And I can graph that. Likewise, I'm now going to replace the y with 0 and solve for x. So 6x plus 2y, that's 0, equals 12, plus 2x. So this goes away. I'm going to subtract 2x from both sides. And I have 4x equals 12. Divide both sides by 4. And x equals 3. So here when y equals 0, x equals 3. X equals 3 is right here. And I take my ruler and I make a nice straight line. So hopefully you can see that using these zeros is really much simpler. Okay, let's substitute on this next problem. X equals 0. We've got 2/3 times 0 plus 3 equals negative 3y. Well, anything times 0 goes away. We've got 3 equals negative 3y. Go directly to the unknown, look what's around it, undo it. I'm going to do that with division. And y equals negative 1. Likewise, we're going to say 2/3 x plus 3 equals negative 3 times y. Now that's 0. We've got 2/3 x plus 3 equals 0. We're going to subtract 3 from both sides. And we end up with 2/3 x equals negative 3. Multiply both sides by 3. Get rid of that fraction. And we have 2x equals negative 9. And divide both sides by 2. And we have x equals negative 9 halves. Negative 9 halves, if we divide 9 by 2, we're going to end up with negative 4. and 1/2. So we've got -4 and 1/2 here for our intercept. So let's graph these. 0, -1, x equals 0, y equals -1. That would be right here for our y-intercept. And -4.5, that would be between the -4 and the -5 for x, and 0 for y, right there in the middle. And we're going to take our ruler and connect the 2 points. And that's how you graph a linear function using the x and y intercepts. Thanks for listening.